The equivalent conductance of 0.1 normal MgCl2 solution is 97.1 Simon centimeter square equivalent inverse at 298 Kelvin. A cell with electrodes that are 1.5 centimeter square in surface area and 0.5 centimeters apart is filled with 0.1 normal MgCl2 solution. How much current flows when potential difference between the electrodes is 5 volts? Here first we'll calculate the K value by using concentration and equivalent conductance. Equivalent conductance is given in centimeters. So lambda eq is equal to K into 1000 by C. So here lambda eq value is 97.1 is equal to K into 1000 by C. Concentration is 0.1. If you calculate K value will get 9.71 into 10 power minus 3 Simon centimeter inverse. Then by using this K value we can calculate the resistance. We have the formula K is equal to G into G star, where G is a conductance, and G star is cell constant. Here conductance, in place of G we can write it as reciprocal of resistance 1 by R, and G star cell constant is L by A. K is 9.71 into 10 power minus 3 is equal to 1 by R into L is 0.5, A is 1.5. From this R is equal to 0.5 by 9.71 into 10 power minus 3 into 1.5. Then R is equal to 0.5 by 14.565 into 10 power 3. We'll get R value 34.3 ohms. R value is 34.3 ohms. Then V, potential difference V is equal to current into resistance I into R. Potential difference is 5, I into resistance is 34.3. From this I is equal to 0.1457 amperes. So the current, how much current flows when potential difference between the electrodes is 5 volts, that is 0.1457 amperes.